All right, welcome to another session of Krazifizix Maths and Science. In this session, we're looking at Maths Paper 1, a continuation of our video. So this is part B of KZN 2016. Remember, you can reach us on www.krazifizix.org.za. Send us an email at info@krazifizix.org.za, and we will be able to assist you with your emails. All right, quickly, let's run to the question. We're starting from functions in this part of the video. All right, the diagram below shows the graph of h of x, which is written as a over x plus p plus q. And our asymptote, x equals to 3, because we can see that here, all right, and y equals to -2. First question says write down the values of p and q. All right, if you look at this here, x plus p, that's how you get the equation of your asymptote, must be equal to 0. But x equals to what? 3. All right, so 3 plus p equals to 0. What is p? -3. All right, that's one way to do it. Or you just simply say x plus 3 equals to 0, and x equals to, okay, we said x equals to 3. All right, that's what we're given, which means x minus 3 equals to 0. And if you compare that with x plus p equals to 0, your p is -3. Great. And your q is simply -2, because that's your y asymptote. All right, calculate the values of a. So what's my new equation? H of x equals to a over x minus 3 minus 2. What do I know? P is a point on h. All right, and my x equals to 4. Y equals to -4. So -4 equals to a over 4 minus 3 minus 2. If we bring this here, what are we going to have? -4 plus 2 equals to a over 1. So 2 minus 4, a equals to -2. And you're done quickly with that question. Now it says calculate the coordinate of the y-intercept of h. What do we know? With y-intercept, our x equals to 0. All right, y-intercept, our x value is equal to 0. So what do we do quickly on that equation there? We just basically substitute our values. All right, so what is our h of x? Our h of x equals to -2 over x minus 3 minus 2. But now I am saying that my x equals to 0. So h of 0 equals to -2 over 0 minus 3 minus 2. All right, if you use your calculator here, you are going to get -2 over -3, right? Which would give me 2 over 3 minus 2, and that will give me -1/3. All right, it says coordinates, so we must write down the coordinates. The coordinates are 0 into -1/3 there. All right, awesome. We'll run quickly. This session is going to be quite short. If g of x is h of x plus 2, write down the equation of the vertical asymptote of g. Okay, they're saying g of x, that's our new equation, is h of x plus 2. By the way, what's my h of x? My h of x is -2 over x minus 3 minus 2. What we do is anywhere we see x now, we write x plus 2. So my g of x is now -2 over x. Remember, I'm replacing x with that, minus 3 equal minus 2. So let's solve this. 2 minus 3. I have -2 over x minus 1 equals to -2. So what is my asymptote now? My asymptote, x minus 1 equals to 0, x equals to 1. And that's how we get that. All right. If the graph of h is symmetrical about the line y equals to -x plus c, determine the value of c. All right. What do we know quickly? Now, this is talking about a line of symmetry, and it's a negative gradient. A negative gradient. Okay. What now? Remember, we're dealing with h of x. What is my h of x again? Quickly. What are the points? Okay, what my y and my x would be the point of intersection. because this is the line of symmetry. Point of intersection of asymptotes. All right, asymptotes. Remember, my x was -3 and my y was what? -2. Okay, but now it says if the graph of h is symmetrical about the line, symmetrical about the line. No, my x is +3. My x is +3. Okay, my x is +3. So it's 3. That's the coordinate there. All right, we can simply use our equation of a straight line. All right, so if I have that, what is my y value? -2 equals to -3 plus c. All right, what am I going to have? My c will be equal to what? 1. That's correct there. Or you can use the general formula as well, plus q. Okay, and what would that be? What would that be? -x minus 3. This is y. All right, because my p is -3 and my q is what? -2. What am I going to have? -x plus 3 minus what? -2. So y equals to -x, 3 minus 2 plus 1. Do you see again here? If we compare this, y equals to -x plus c. My c equals to, and that is question 6, done and dusted. Please rewind the video. All right, rewind the video and watch it again. Let's run to question number 7. All right, the graph below shows the graph of g of x, which is x squared minus 3x minus 10. That's a parabolic graph there. And h of x, which is ax plus q, straight line graph. The graphs intersect at point B and D. The graph of g intersects the x-axis at A and B, and has a turning point at C. All right, it's all there on the graph. The graph of h intersects the y-axis at D and the x-axis at B. Everything is right stated here. Write down the coordinate of D. All right, write down the coordinate of D. If you look at your g of x, D actually rests on g of x, right? And my g of x is what? X squared minus 3x minus 10. What do you notice at D? My x equals to what? 0. So g of 0 will be 0 squared minus 3, 0, 10. And what's my answer? My answer is negative what? 10. So what is my coordinate? That's my y value, remember? So my d is 0 is to 10. And you're done. You need to see what's on the graph. Determine the coordinate of A and B. Okay, what's my g of x? My g of x equals to x squared minus 3x. What do you notice about A and B? They are my x-intercept. Automatically, my y should be equal to 0. All right, this takes you back to question 1, where you need to learn to factorize. Okay, if I open a bracket quickly, I know you know what to do. From here, it is x and x. The two numbers I need to multiply are 5 and 2. All right, but how do I get minus? It is 2 minus 5. All right, so x equals to -2, or x equals to what? 5. The negative, which one is negative? The negative is the a. So what is my a coordinate? X is -2 and y is 0. What is my b coordinate? X equals to 5 and y equals to what? 0. And you're done quickly. Write down the values of a and q. Okay, h of x equals to what? Ax plus q. Let's go look at that quickly. What is my q? My q is my y what? Intercept. And already we got that here because it's intercept at D. So this is -10. All right. Now what is A? A is the gradient. Okay? A is the gradient of my straight line. But what do you know here quickly? All right. Our point D, quickly. Our point D, x is 0 and y is -10. Our point B, x is 5 and y is 0. So we can calculate gradient there quickly. A equals to y2. Okay, let's M equals to y2 minus y1 over x2 minus x1. All right, because we're looking for gradient of a straight line. All right, so I can easily say 0 minus negative 10 over what? 5 minus 0. And that will give me 2. So my gradient A equals to 2 and my Q is negative what? 10. All right, so functions is actually quite very easy to run through. Calculate the coordinates of C, which is the turning point of G. How do you calculate turning point? X equals to negative B over 2A. Remember, my G of X is equal to what? X squared minus 3X minus 10. So turning point, A is 1, B. So negative 3 over 2 multiplied by 1. My X value is actually 3 over 2. What do you do to get your Y value? Substitute the value of X in the original function. In the original function. All right? So, G of 3 over 2 is equal to what? 3 over 2 squared minus 3, 10. All right, let's run to our calculator quickly. What do I have? It is, I have 3 over 2 squared. So it's 3 over 2. Okay, my bracket needs to come out there. Squared. All right. Minus 3 into bracket. What do I have? 3 over 2. We close the bracket. Minus 10. And our answer is negative 49 over 4. All right. Negative 49 over 4. You can basically leave it like that. All right. Negative 49 over 4. So my G of 3 over 2 equals to what? Negative 49 over 4. So what is the coordinate of C? My turning point is 3 over 2 is to negative 49 over 4. And we are done there. All right. 7.5. Okay. 7.5. Write down the turning point of T. If T of X is equal to G of negative X plus 3. Okay, let's write that down. T of X is equal to what? G of negative X. Okay, my board equals to G of negative what? X. All right, plus 3. Okay, let's quickly recalibrate this board. T of X equals to G of negative X plus 3. All right, T of X. Now, what is my G of X? Let's quickly write down our G of X. Our G of X was the straight line. Let's check quickly. Oh, our G of X is negative what? No, X squared minus 3X minus 10. All right, but we want G of negative X. All right, that's my G of X. But if you notice something here, the examiner is quite tricky here. It says G of negative X. What does it mean? We have reflected this graph, all right, along the Y, because this is my Y value. So our graph now is reflected and our graph looks this way. So what happens? My X value becomes what? Negative. And what was my X value of point C? It was 1 over, was it 1 over 5? It was 3 over 2. 3 over 2. All right, so automatically, what is my X value now? My X value is negative 3 over 2. What about this plus 3? This graph is now shifting upwards 3 units. What was my coordinate of C there? It was 49 over 4. But if I shift up 3 units, what do? I now say negative 49 over 4 plus what? 3. I think I still have my answer there. All right, plus 3. What do I have? Negative 37 over 4. So my coordinate is my Y value. I am shifting the graph up now with 3 units. I have what? Negative 37 over 4. So what is my coordinate? My new coordinate of C is now negative 1 comma 5. Remember, we're shifting along the y. So x becomes what? Negative, and negative 37 over 4. Okay, but since we are using, okay, here, negative 3 over 2. If you are using decimals, it becomes negative 1 comma 5. All right, and this answer gives you, let's check what this answer would give you, negative 9 comma 25. All right, that's how you work such questions. So it's just a matter of reflection and shifting. For which values of x will g prime of x multiplied by h prime of x be greater than, all right, it says g prime of x, which is the derivative, h prime of x also be greater than what? Or equal to 0. By the way, we know our g of x, right? Which we can quickly derive. What's our, let's go check quickly. Derivative here would be what? 2x minus 3. Okay, is that making sense to us? And our h of x, what is our h of x? Our h of x was 2x minus what? 10. All right, 2x minus 10. If we derive this, what are we going to have? We are going to have what? 2 greater than or equal to 0. We can basically expand this to give us 4x minus 6 greater than or equal to 0. 4x greater than or equal to what? 6. X must be greater than or equal to 3 over 2. And you work that out. Those, some you can work algebraically, and the others you have to use the graph. Question 7 is absolutely done. Let's run to question 8. Given that p of x is 3, all right, exponential there. Write down the equation of p inverse, all right? 1, what we know that this is this, right? Okay, so what is my p inverse of x? What do I do? Anywhere I see x, I make it y. So x equals to 3 to the power what? Y. What you do here, you introduce your logs. Take log base 3 of both sides. So I'm going to have what? Log 3 there, log base 3 there equals to what? Y. And that's my answer. Okay, just take the log 3, base 3, all right? And then you get your answer very, very fast. Sketch in your answer book the graphs of p and p inverse on the same system of axes, all right? It is always easier. Start with the first one. Okay, my p of x. What do we know again? My p here. All you need to quickly get is your intercept. If x equals to 0, so my p0 equals to what? 1, because it's 3 to the power 0. So what do I know? I know there's a positive 1 there. And because it's an exponential graph, which is positive, my graph should be increasing. And also my x is a positive value. So I should have a graph that goes this way. Okay. I should have a graph that goes that way. So I know this point as point 1 there. All right. And then what do we know again? What can we get? What can we get quickly? What can we quickly get? Now, on this graph here, what is the value of y when x equals to 1? All right, remember my y equals to 3 to the power x. So if x is 1, y is equal to what? 3. So I definitely know a point on this graph here, somewhere here, 1 and 3. Now, if I am dealing with the inverse, remember here, I want to draw the inverse now. Here, what am I saying? This is my y value, and this is my x value. When x equals to 0, y equals to what? 1. I want to find the inverse now. What's going to happen? We invert this now. It means I'm going to have a 1 and a 0. When x equals to 1, y equals to 0. So that means my x-intercept will be there. And then this point as well will now change and become 3:1. What will my graph now look like? All right, it is just the inverse now. And what is this point now? This point is going to be 1 and 0. And when my x equals to 3, somewhere here, my y equals to what? 1. And then we are done. But you must also show your line of your symmetrical line there across the origin. And that's what you do. All right, 8.3. Determine the value of x for which P inverse of x is less than 3. P inverse of x less than 3. Okay, but we know our P inverse, right? We said it is log base 3x. All right, let's say that is equals to 3. What am I going to have? X equals to 3 cubed. So x should be equal to what? 27. Now remember, you cannot have the log of a negative number, so it must not go below 0. Below 0. So my x should be greater than 0, but less than or equal to what? 27. Always remember, when it comes to log, here you are going to get no solution. So when it comes to log, please remember, don't go beyond the 0 margin. Okay. Question 9. Given f of x equals to x cubed, derive from first derivative. Please keep your answer somewhere. My answer should be what? 3x squared. All right, so what am I going to have? Remember, my f prime of x is what? Limit as h tends to 0, fx plus h minus f of x over h. What do we do there now? Okay, space. Because of space, I'm going to remove that, but I need to keep writing limit. What am I going to have? X plus h cubed minus x cubed over what? H. All right, let's continue quickly. You need to keep the limit flowing. All right, and if we expand this, guys, you should be able to expand this. Please expand. You're going to have x cubed plus 3. Now your x value exponent starts decreasing while h increases. All right, again it's 3x. All right, you see, it's just interchanging, but 2 plus 1 would give me 3, and then I have what? H cubed minus x cubed over h. That and that would cancel. What are we going to have? Limit as h tends to 0. Okay, here we can quickly factorize. If we factorize, h is common, so I'm going to have what? 3x squared plus 3xh plus h squared, everything divided by h, which divides each other there. And now, if I substitute my h as 0, then I don't write limit anymore. I'm going to have 3x squared plus 3x multiplied by 0 plus 0 squared. And my answer is 3x squared. All done and dusted. Okay, 9.2.1. F of x is given as root x minus 4 over x squared. Please don't differentiate at this level with x as a denominator. So we need to quickly solve this. This is x to the power half minus 4x to the power negative 2. So what is my derivative? I'm going to have half x. Now half minus 1, that's the rule. Half minus 1 would give me negative half. Okay, minus. We multiply negative 4 and negative 2. I'm going to have 8 there. And then we subtract again minus 1. So it's minus 2 minus 1. Negative what? 3. And that is my answer. Okay, done. Look at the next one. We should derive again half x squared minus 3 equals to square root of y. What do we need to do? Solve first. By solving, I can square both sides. All right? So what am I going to have? Y equals to half x squared minus 3 squared. Okay, which basically I can say half x squared minus what? 3. Now, what is my y? If I were to do this, half times half would give me 1 over 4 and x to the power 4. All right? Half x times 3 would give me negative 3 over 2 x squared. I'm going to repeat that again, negative 3 x squared positive 9. So what would my y be? 1 over 4 x to the power 4. Now if you solve this, negative 3 over 2 plus minus negative 3 over 2 should give you negative 3 x squared plus 9. How do you now derive? dy dx, it becomes 4 times 1 over 4, and that gives me 1. All right, so I have 1 there, but I have to subtract 1 from my exponent. 4 minus 1, 3. Again, minus. 2 multiplied by 3 will give me what? 6x. Then I come here and subtract 1 again. 2 minus 1 would give me what? 1. And anytime I differentiate a constant, it's a 0. So what's my answer? X cubed minus 6x. It is easier if you solve before you derive. Okay, question number 10. All right, applications now. Given f of x equals to x squared minus 8, calculate f of negative 3. All right, that is an examiner being extremely nice here. What do? We just replace negative 3 squared minus 8. What are we going to get? That will be 9 minus 8. That gives me what? 1. That's 1 mark there. Calculate f inverse of negative 3, f prime of negative 3. It means first, guys, we need to derive. What's my derivative? 2 times 1 will give me what? 2, and I have what? X there, because I'm saying 2 minus 1 on the exponent. Now, f prime of negative 3, what would that be? 2 times negative 3, and that gives me negative 6. Okay, this examiner is linear questions. All right, but it's basic things that we need to quickly know. Determine the equation of the tangent of f of x, all right, x squared minus 8 at x equals to negative 3. Now, what you need to quickly know, okay, what's my f of x? My f of x is what? X squared minus 8 at x equals to negative 3. We want the equation of a tangent, which is y equals to what? Mx plus c. Please understand that your f derivative is equal to your gradient. And already in this question, because my x is negative 3, which is here, I already have my gradient, all right, which is what? Negative 6. Okay, now the question is, what is my y value? By the way, we already know that when x is negative 3, back in the original equation, my y value equals to 1. I hope that makes sense. When x is negative 3, to get y value, I always substitute in the original what? Equation. So I've got 3 things. M equals to negative 6. X equals to negative 3. And y equals to 1. Okay, there are 2 ways, but let me just quickly do one quick, that is probably what we're familiar with. Y minus 1 equals to negative 6x minus what? 3. These are my x and y values. Y equals to negative 6x. Now, negative times negative will give me negative, right? And 6 times 3 would give me negative 18. If I move this one over, it becomes what? Positive 1. All right? So what's my answer? My y equals to negative 6x minus 17. Alternatively, you can say y equals to mx plus c. What's my y value? 1. Negative 6. What's my x value? Negative 3 plus c. 1 equals to negative 18. Positive 18 plus c. All right, so 1 minus 18 equals to c. What is c? Negative what? 17. So I come back here and replace my values. My y would be equal to negative 6x minus what? 17, which gives me the same answer there. All right, 10.2 quickly. 10.2. So this video is going to be short because this section is just moving so smoothly. The graph of a cubic function f of x equals to x cubed minus 3x minus 2 and g of x of 2x minus 2 is drawn. A and B are the turning points. P is the point on G and Q is the point on F such that PQ is perpendicular. First question, calculate the coordinates of A and B. These are my turning points. And with a cubic function, please understand quickly, your first derivative equals to 0 is the turning point, which is also my maximum and my minimum. So what is my what's f of x quickly? X cubed minus 3x minus 2. Let's derive. What are we going to have? 3x squared minus what? 3. And this now should be equal to 0. Okay, what's common here? 3 x squared minus 1. X squared minus 1 equals to 0. So how do we solve x squared minus 1 equals to 0. All right. There are two ways to do this. You can say x squared equals to 1 and x equals to the square root of 1, which is plus or minus what? 1 there. So it's either x is negative 1 or 1 or negative 1. Or from here, you can use your difference of 2 squared. X squared minus 1 is actually x plus 1. X minus 1 equals to 0. So x equals to negative 1 or 1. But I am looking for coordinate. What do? I replace the value of x in the original. Oh, by the way, yeah, in the original equation. Already I know here so I have negative 1 as the value of x, and I have 1 there. But you notice this side is already on my x-axis. So my a is actually negative 1 and 0. What do I need to do? I need to put 1 now in my original what? Function. So I'm going to have f of 1 equals to 1 cubed minus 3 times 1 minus 2. All right, so it's 1 minus 3 minus 2. And that will give me negative 4. So what's the coordinate of b? Coordinate of b is 1 is to negative what? 4. Great. If PQ is perpendicular to the x-axis, okay, we're given that. Calculate the maximum length of PQ. I want you to notice something here. Here we are talking about y values. All right, we're talking about y values. So it is the difference, PQ is the difference between g of x and f of x. All right, g of x minus f of x. That is going to be my PQ. What is the equation of P? P is a straight line. All right? Okay, PQ is a straight line there. So what is my G of x? My G of x is given as 2x minus 2. So PQ equals to what? 2x minus 2 minus, what is my f of x? X cubed minus 3x minus 2. We're just substituting there quickly. So if we were to expand all of this, 2x minus 2, all right, minus x cubed plus 3x plus 2. Okay, let's solve this algebraically. All right, plus 2. Okay, negative 2 will go there. What do I have left? Negative x cubed. Now 3x plus 2x would give me 5x. All right, but the question says the maximum. Once you hear the word maximum and minimum, you derive. It's your first derivative. Will now be equal to what? Negative 3x squared plus 5 equals to what? 0. Negative 3x squared equals to negative 5. X squared equals to 5 over 3. So what is my x value? It is the square root of 5 over 3, which is equal to plus or minus 5 over 3. All right, plus or minus 5 over 3. What do we now say? Because we want the maximum. The maximum, for maximum, x has to be what? Positive 5 over 3. What do? I go back and substitute in my equation, which is PQ. What is my PQ? We got negative x cubed, all right, plus 5x. That's the equation we got. So negative 5 over 3 cubed, all right, plus 5 into 5 over 3. Let's get our answer quickly. We're going to have negative, okay, I need to open my bracket there, 5 over 3, and then we have cube there, plus 5, we have another bracket, open there, 5 over 3, we close the bracket, and what's my answer? 100 over 27, which is actually 3,7. All right, negative 5 over 3. No, positive 5 over 3 there. All right, so what's my answer? My answer is 3,7. 3,7. Okay, there's something omitted right here. Just quickly going to run back to it. We said we actually need to introduce that there. All right, so what is the square root of, square root of 5 over 3? That is equal to what? 1,29. All right, so x is equal to positive 1,29. Remember, we're using the positive one because we're talking about maximum. 1,29 cubed plus 5, 1,29. What am I going to have? Okay, let's quickly substitute that. It's negative 1,29, negative 1,29, and then we have a cube there, all right, plus 5, 1,29. What's my answer? 4,3. All right, so my maximum length is actually 4,3 units. Remember, I'm using positive because it is maximum. Determine the values of k for which f of k has only 2 real roots. Okay, real means that my graph must actually cut the x-axis. But since they said 2, let's see something here. I'm just going to quickly put a sketch of this graph. All right, that's my f of x. For this to have 2, okay, what's my a? My a is negative 1 and 0. Okay, what is my b? We got our b value. Our b value was negative 1. Okay. Now, for this to have 2 roots, it means that this graph must cut the x-axis just twice. Now, this b is negative 1. All right, it's negative 1 and negative, no, it's positive 1 here. All right, positive 1 and negative 4. All right, for this thing to have 2 real roots, what does it mean? It must cut the graph twice, and which is 1 here. And if I draw my x-axis, look at this blue line. There, it gives me 2 roots. So what are my values? My k must be equal to negative 4, or my k equals to what? 0. Why is that so? Look at this red line. If at any other point, I'm going to draw so many points, so you need to follow through. If my x were to be above 0 here, or my k above 0, it's going to cut this graph only once. If it's in between 0, if it's in between 0 and negative 4, anywhere here, it is going to cut the graph 3 times. So here I'm going to have 3 values. Here I'm going to have 1 value. If it is below my turning point, it is again going to cut the graph just once. I'm going to have 1 value. But here I have 2, just at my turning point. All right, I have that 1 and 2, and I have 1 and 2 at my turning point, and my turning point value negative 4 and 0. All right, awesome. 10.2.4. Determine the value of x for which f is concave up. All right, I don't want to go into a new page, so I'm quickly going to clean this. Concave up, what you need to remember, the second derivative must be greater than 0. All right, what do we know? My first derivative, let's just quickly remind ourselves, it's 3x squared minus 3. Now, what's my second derivative? Derive this again. It's 6x. So we're saying 6x must be greater than 0, which means divide both sides by 6x must be greater than 0. That's one way. Or concave up, x equals to negative b over 3a. All right? Negative, what is my b? My b is negative 3. All right? Over 3. Okay, negative b over 3a. Now what's my equation again? F of x. Okay, I'm going to need to actually show something very, very quickly here. All right, how do we use negative b over 3a? I'm sure you got that quickly, second derivative there. What is my f of x? My f of x is x cubed minus 3x minus 2. But my equation actually should be ax cubed plus bx squared plus cx plus d. Do you notice here there is no x squared? It means my b equals to 0 and my a equals to 1. So Concave. All right, negative b over 3a. What do I have? Negative 0 over 3 multiplied by 1, which is equal to what? 0. All right, so what do I know? My x must be greater than 0. All right, awesome there. Quickly now, let's look at the next question. All right, a car speeds along a 1 kilometer track in 25 seconds. Its distance in meters from the start after t seconds is given by, so the distance. All right, this would be actually nice for those of you doing physical sciences. Write down an expression for the speed, which is the rate of change of distance with respect to time of the car after t seconds. All right, write down an expression after t seconds. Guys, whenever they say rate, we are going to differentiate, and speed is actually represented with v, but you don't need to remember the symbol. All you need to do is to differentiate with respect. Once you see rate, it means differentiate. So what are we going to have? 2t plus 15, and we're done. Rate means differentiate. Determine the speed of the car when it crosses the finishing line. I am looking for speed, all right, which is the rate of change. So, and it drives for how many seconds? 25. So my time is 2 times 25 plus 15. All right, that is 50 plus 15. That gives us what? 65 meters per second. Okay. Write down an expression for acceleration, the rate of change of speed. What are we saying? Again, rate, we derive. What are we deriving? Speed. Remember, we have our speed. This is the formula for speed. 2t plus 15. What do we do now? We derive the second time, and that will give us what? 2. And this is meters per second squared. All right. Okay. 11.4. Hence or otherwise, calculate the acceleration of the speed. Acceleration is the rate of change of speed. So, at how many seconds? At 5. All right? At 5. Now, do you notice there's no t value here? So my answer remains what? 2 meters per second. If there was a t value, I would substitute. But because there's no t value, it is just a constant there. Calculate the speed of the car when it is 250 meters down the track. I am looking for the speed of the car. All right, remember that the distance is t squared plus what? 15t. That's the distance because we are given 250 meters. What does it mean now? It means our speed now, the distance, is actually now equal to 250. So t squared plus 15t should be equal to 250. What do we do? This looks like a quadratic. Plus 15t minus 250 equals to 0. Okay, what are the things that will give me 250? Quickly, 25 and 10. Because 25, 10 will give me what? 15. All right, so there are some numbers that you must be smart with as a math learner. I know some of you would run to your quadratic quickly. I want a positive 15. So it's going to be positive 25 minus that equals to 0. So t equals to negative 25 or t equals to what? 10. But my time cannot be negative. So I'm going to use t equals to 10. But by the way, I am looking for speed. Remember, our speed was our first derivative. And our first derivative was what? 2t plus 15, which is 2 multiplied by 10 plus 15, and that should give us what? 20 plus 15, 35 meters per second. All right, that's how we work out the whole question. Let's look at the last question, question number 12 quickly. All right, this is probability, the last question. A study on eating chocolate and gender yielded the following results. So we have all the statistics here. Okay. Male 45 eating chocolate and all the statistics given. How many people participated in the study? Do you notice the number of people eating chocolate is 80? The number of people not eating chocolate is 70. The total is what? 150. So 12.1.1. How many people participated? 150. That's a free mark there. Calculate the following probabilities. Probability of male. Probability of male would be total number of male divided by the total what? Outcomes. The total number of male, 45 are eating chocolate, 25 are not eating chocolate. So it's 70 over 150, which is basically 7 over 15. You must leave it in the simplest form. Calculate the probability of people eating chocolate. All right, eating chocolate, eating. How many people are eating chocolate? It's actually 80. So 80 over 150, which gives me what? 8 over 15. All right. Are the events being male and eating chocolate independent? Justify your answer. Okay, let's see quickly. Independent events. Independent events. Let's check. Independent events. How do we prove independency of an event? We must prove that probability of male, all right, and probability of eating chocolate, all right, must be equal to probability of male times probability of eating what? Chocolate. Now, what is the probability of male and chocolate? Male eating chocolate is 45. So on the side, I have 45 over 150. All right, 45 over 150, which will give me, let's see what 45 over 150 would give us. 45 divided by 150, 45 divided by 150 would actually give me 3 over 10. All right, so here my answer is 3 over 10. Please always leave your answer as simplest. All right, 3 over 10. But what is the probability of male times probability of chocolate? We had our answers a while ago. Probability of male was actually 7 over 15, and the probability of chocolate was 8 over what? Of male eating chocolate. So we have 7 over 15 times what? 8 over 15. That should give us what? Let's just quickly check. We need a final answer. It is 7 over 15 times 8 over 15. And what do we have? 55 over 225, which is basically 0.25. It's 248. All right, so 25. This is 0.25. On the other hand, this is 0.3. So they are not equal. Since they are not equal, they are what? Not independent. All right, so events are not what? Independent. Why are we saying they are not independent? Probability of male and eating chocolate is not equal to probability of male times probability of eating what? Chocolate. Great. Now let's run to permutations. 4-digit codes not beginning with 0 are to be constructed from the set of events 1, 3, 4, 6, 7, 8, and 0. How many 4-digit code can be constructed if repetition of digits is allowed? Now, how many digits do I have here? I have 1, 3, 4, 6, 7, 8, 0. 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers in all. But the instruction says it cannot begin with 0. I need a 4-digit code. All right, I need a 4-digit code, which means I can only put 6 numbers here. All these numbers except 0. But I can repeat. It says repetition is allowed. So here I can repeat all the 7, including 0. I can repeat 7. I can repeat 7. So it's 6 multiplied by 7, multiplied by 7, and multiplied by 7. What do I have? 6 multiplied by 7, multiplied by 7, multiplied by 7. What's my answer there? 2058. 2058. All right. How many 4 digits can be constructed if repetition of digits is not allowed? Repetition of digits is not allowed. All right. Remember, I still cannot start with 0, so I'm going to be left with 6. 6 numbers out of 7. But I cannot repeat this number. I'm going to have, instead of 7 here, I'm going to have 6 because 0 is now included. But I cannot repeat these 2 numbers out of 7. I'm going to have 5. I cannot repeat these 3 numbers. I'm going to have what? 4. So it's 6 times 6 times 5 times 4. And what would that be? 6 times 6 times 5 times 4. 6 times 6 times 5 times 4. What is that? 720. So that's how we work things out. Okay, the last question. Calculate the probability of randomly constructing a 4-digit number which is divisible by 5, okay, if repetition of digits is allowed. It's divisible by 5. Again, what are my numbers? Let me put my numbers here for visibility. It's 1, 3, 4, 6, 1, 3, 4, 6, 7, 8, and 0. If it is divisible by 5, my number can only end with a 0. Because all these other numbers are not divisible by 5. So my last number must be a 0. That means then I will have 1 here because 0 is the only number that I can have. They said if repetition of digits is allowed. By the way, I still cannot start with a 0. So I have 6. But I can repeat any of these numbers. So it's 7. Again, repeat 7. All right. So, but I'm looking for probability, which is possible outcomes over total outcomes. So this is 6 times 7 times 7 times 1 over 2058. Remember, my total outcome from the first question is 2058. So what do I have? I have 6 times 7 times 7. 6 times 7. Okay, 6 times 7 times 7 times 1. All right, 294 divided by what? 2058. Okay, 20. All right, my calculator now is trying to be. Let's shift this a bit here. It's my 2058. And what's my answer? My answer is 1 over 7. All right, 1 over 7. All right, 1 over 7. Okay, and that is my answer there. 1 over 7. Let's just check again quickly. 6 times 7 times 7 times 1 would give me what? 294. 294, all right, divided by 2058, and that gives me what? 1 over 7. All right, so that's the probability there. It's 1 over 7. All right, end of the paper, guys. This is how we work through all our papers. Remember, you can rewind the video here and there to just check clarity of things that we did. All right, this is another production of Krazifizix, and here again is our info. We've got our materials as well. For more information, please check on our website. You'll actually find what you need there. Send us an email, send us a message from the site, and we'll be able to respond to you. Here's our maths product. It's called Krazifizix Mathematics Spectrum. It is one book for 3 years because maths is progressive from grade 10 to 12. Hope you enjoyed the video. Stay blessed and watch over and over again. Keep well.